All right, so let's talk about the 4 quadrants on the coordinate plane here together. And you're going to notice that once we get past the new material, it's very much like what we've been doing for the last few lessons. Let's just jump right in and try something here together. So let's call this example 1. So I want to let negative 3, 4 be a point on the terminal side of an angle. So we'll call that angle theta. And what I want to do is I want to be able to find sine of theta, cosine of theta, and tangent of theta. So we're going to start this out by drawing a coordinate plane and plotting the point negative 3, 4. So I'll plot the point negative 3, 4. And that's like right here. And what I have to do is I have to draw in the angle. So I'm going to imagine that I rotated from 0 degrees to that point, and then I'm going to draw in something that creates an angle there for me. The next thing I have to do is I'm going to resort back to my triangles and using a right triangle here. So in order to draw my right triangle, I am always going to go from where my angle stopped, so at that point, perpendicular to the x-axis, and then I draw in the rest of that triangle. So going back to what we did on previous sections, we have a triangle that looks like this. Now let's talk a little bit about what's going on in that triangle. So the x-coordinate is negative 3. That means we moved to the left negative 3. So we went this way 3 units. We show that by saying the direction and the length gives me a total representation of negative 3, 4. Then I moved up 4 to get to this point. So I'm going to call my upward movement 4. Now hopefully you recognize that this is a Pythagorean triple. It's a right triangle that has sides 3, 4. Then the hypotenuse would have to be 5. So without using the Pythagorean theorem, I could find the hypotenuse is 5. What I want to be careful in paying attention to is that the length of this side is 3, but the movement in how we got to that point is left 3. So on the triangle, I'm going to write negative 3. But when I go to use the Pythagorean theorem, if I need to use the Pythagorean theorem, I would just put 3. Okay, so we have to find 3 representations here: sine, cosine, and tangent. And this is just like what you've been doing. So we look at that and we say, okay, our sine is the opposite side over the hypotenuse. So in our triangle, that would be 4 over 5. Our cosine is the adjacent side over the hypotenuse. So in our triangle, that's negative 3 over 5 because we moved left 3. So our adjacent side has that negative movement. And then tangent is opposite over adjacent. All right, so my opposite side is 4, and my adjacent side is negative 3. So I could write it either as 4 over negative 3, or I could just write negative 4/3 if I wanted. Okay, so this brings up a really good kind of question, and that's how do we know when something is going to be negative or positive when we're dealing with our coordinate plane? So let's think about this in terms of we have 4 quadrants on our coordinate plane. There's a little saying that a lot of calculus kids you'll hear them saying, and it's all students take calculus. And the key to this is the first letter of every word. If we write those in order around our coordinate plane, A, S, T, C, going in the same order that they're numbered, this is going to help us identify which trig functions are positive in each quadrant. So in quadrant 1, we see A. A stands for all. So all trig functions are positive in quadrant 1. Okay, S. S stands for sine. So in quadrant 2, only sine is positive. Now, I'm going to make one little exception to that. we're also going to include cosecant because cosecant and sine are just flips of each other. They don't actually change whether they're positive or negative. So if sine is positive, then cosecant is positive. And if sine is negative, then cosecant is negative. Okay. In quadrant 3, T stands for tangent. So only tangent is positive in quadrant 3. Now, I'm also going to make a little exception there and say also cotangent for the same reason that we talked about with sine. And then in quadrant 4, only cosine is positive. And then once again, you can probably figure out that I'm going to say also secant. All right, so knowing that, we can start to ask ourselves some questions like, what quadrant are we in, or where is theta if the tangent of theta is less than 0 and the cosine of theta is less than 0? So when I approach a problem like this, I start again by just drawing in a coordinate plane, and I label it with ASTC, all students take calculus. And I have to think about the fact that if tangent is negative, or if tangent is less than 0, that means I'm saying tangent is negative. All numbers less than 0 are negative. Then if cosine is negative, that also means cosine, or cosine is less than 0, that also means cosine is negative. So I'm going to start to rule out quadrants that these could be in. So if I'm saying tangent is negative, then we can't be in quadrant 3, because in quadrant 3, tangent has to be positive. Same thing with cosine. If cosine is negative, I can rule out where we said cosine has to be positive. And then hopefully we recognize that if we're saying tangent is negative and cosine is negative, we can't be in quadrant 1 because everything is positive in quadrant 1. So that means our angle would have to be in quadrant 2. Okay, let's try another one. So where is theta if cosecant of theta is negative or less than 0 and secant of theta is greater than 0? So now we're saying cosecant is negative. Well, if cosecant is negative, we also know that sine has to be negative. Okay, so that's really giving us that sine is negative. If secant is positive, greater than 0, that means it has to be positive, then that means that cosine is positive. So once again, I'll draw myself a little coordinate plane here and just fill it in with ASTC and start to eliminate some quadrants where my angle couldn't be. So cosecant or sine is negative. That means it can't be here because sine has to be positive there. It also couldn't be here because everything is positive there. And then cosine is positive. Well, we know cosine is positive in quadrant 4, but we also know that only tangent is positive in quadrant 3, so we can eliminate quadrant 3. So then we would say that our angle theta is in quadrant 4. All right, so let's try putting all of this together. So I'm going to give you that tangent is negative 5/4 and that cosine is greater than 0. So let's just explore that for a moment. When I say tangent is negative 5/4, I'm giving you that tangent is negative. Okay, so I'm going to write that down. And when I say cosine is greater than 0, that means cosine is positive. So once again, let's figure out which quadrant we're in. And I'm going to start by just drawing kind of a mini coordinate plane here because I don't want to actually draw my triangle in this. I just want to figure out which quadrant will I need to draw my triangle in. So if tangent is negative, we can't be in quadrant 3 because in quadrant 3, tangent is positive. We also could not be in quadrant 1 because everything's positive. So that leaves us quadrant 2 and quadrant 4. Well, we know cosine is positive and only sine is positive in quadrant 2, so we can eliminate quadrant 2. So that means our angle has to take place in quadrant 4. So now let me draw an actual coordinate plane where I can put my triangle in. So I'm going to draw my coordinate plane. And remember, I have to draw my angle in the proper quadrant. So this time it's in quadrant 4. That's what we just figured out. So I'm going to draw it in quadrant 4. It does not matter what this angle looks like. I just drew a random angle in quadrant 4. Now I'm going to connect where my angle ended back to the x-axis with a right angle, and then finish drawing my triangle. So I have my right angle here, theta here, and now let's fill in what we know. So we're told that tangent of theta is -5/4, but here's the thing. I don't know just from that whether my opposite side or my adjacent side is going to be negative, because tangent, remember, is opposite over adjacent. So the side opposite of theta would be 5. The side adjacent to theta would be 4. And if I look at where those are in my coordinate plane, I moved right 4 and down 5. So my negative movement is the 5. All right, so I'm going to make that negative. Going to need to use the Pythagorean theorem here. This is not a 3, 4, 5 right triangle because 5 has to be the hypotenuse in that situation, and that's not what we have. So let's find the hypotenuse. I'll do 4 squared plus 5 squared. Now I could say -5 squared, but the length of the side is 5, so I'm going to use 5. The -5 just tells me which direction I moved. So let's see. We've got 16 plus 25, which is 41, and then the square root of 41 is r. So the length of my hypotenuse is the square root of 41. Now, spoiler alert, square root of 41 can't be simplified. It's a prime number, so don't worry about trying to simplify it. But now we have all the information we need to find our trig functions. So sine will be the opposite side, which is -5, over the hypotenuse, which is the square root of 41. And I hope by now you know you need to rationalize that. And that's going to give us a sine value of -5 square root of 41 over 41. Okay, let's find secant. So secant is the hypotenuse, which is the square root of 41, over the adjacent side because it's the reciprocal of cosine. And we don't need to do any simplifying there because we don't have a square root symbol in the denominator. Okay, so once you've got your picture drawn, this is very much like what we've been doing the last couple of days. So it's just figuring out where to place that triangle in the coordinate plane and making sure you have it in the correct quadrant. All right, you've got to go formative to practice some of this with. Good luck. I'll see you tomorrow.